Hi guys, welcome to 6.5, Proving Triangles Are Similar by Angle Similarity. And before we get started, I want to talk about the difference between similarity and congruence. The congruent symbol looks like this. The similarity symbol looks like this. Notice that the congruent symbol has an equal sign and a similarity symbol both together. That means that two things that are congruent have all the characteristics of two shapes that are equal and similar. Okay, so congruent, an easy way to think about that is something that's exactly the same. So if we are looking at two congruent shapes, we know from the past that means that all corresponding angles have to be equal, but also all corresponding sides have to be equal. And if corresponding sides are equal, that also means that they are in the same ratio. And in this case, the ratio is 1 to 1. There's a scale factor of 1 from the one shape to the other. And as you can see, that ties into what makes them similar. So they're equal, but they also have this definition of similars that the sides have to be in the same ratio, and it just happens to be 1 to 1. For similar, obviously we've begun to talk about this. Corresponding angles have to be congruent, but corresponding sides just have to be in the same ratio. So if they were in a 1 to 3 ratio, would look something like this. And of course, you guys know this is not drawn to scale, but 1 to 3 ratio, all the sides are in the same ratio. That's what makes two shapes similar. So looking at our objectives here, in the past we used the angle-side congruence theorem to show that two triangles are congruent. Now we're going to simplify that, and when you take out this side factor and you just have angle, that is enough information to show that two triangles are similar. So take a look on page 381 at this diagram. Basically what they want you to do is to ask, what can you conclude about two triangles if you know two pairs of corresponding angles are congruent? So just by looking at this example, they tell you to draw EFG, with E being 40 degrees, G being 50, and then to draw RST with the same angle criteria there. But you guys know from the constructions we've done in class and your prior knowledge that you would be able to create both of these scenarios with the base leg of EG being longer than RT. So notice that if these were exactly the same, we would have angle, side, angle. That this included side would be the same length. That would make the same triangles exactly the same. But when the included side is not the same size, like this, all that we can conclude is that these are similar. So that takes us to our very first postulate. And if you look on your postulate page that I gave you, there is a section for angle similarity. If you need reference, you'll want to put in that's found on page 381. Okay, so we're going to make a sketch of the concept. So go ahead and draw the sketch right here of how you would demonstrate the angle similarity postulate, which says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are guaranteed to be similar. So go ahead and make that sketch. Okay, so when it comes to what properties are true, we're going to use our first example to kind of illustrate that. So I'd like you to take a look at this example. Determine whether the triangles are similar. If they are, write a similarity statement. Okay, so by thinking about the triangle sum theorem, 26 plus 90 And if you subtract that from 180, that's going to mean this has to be 64 degrees. And the same thing over here, by using the triangle sum theorem, that would be 26 degrees. So in this case, you can see that we have at least two angles congruent in the two triangles, so that makes them similar. So they're similar by the angle-angle similarity theorem. But now we need to write a similarity statement. Okay, and this is what you can copy into the properties that are true. Okay, so what they mean for a similarity statement is something like this. Triangle what is similar to triangle what? Okay, so take a minute to do that. How do you decide the order to list these? I tend to go smallest angle, next largest angle to the largest, so that would be C to E to D. And therefore over here, C is congruent to K over here, so that's listed first, then H, G. Okay, so that should be copied into your notes. So properties that are true is that corresponding angles are congruent. And what else, what other property is true about these two triangles? The sides are in the same ratio. Okay. Notice that many times with the angle-angle similarity theorem, you will have to use the triangle sum theorem to figure out the missing third angle to see if they match up. Okay? All right, take a minute to state the theorem in your own words on your vocab sheet. So you just listed properties that are true. Go over to the last column, state the theorem in your own words down here. And just a reminder, on this vocab sheet, all sections must be filled in and complete for 40 points. And there's a few of you out there that not only does it need to be complete, but it needs to be legible. And it needs to be legible at an 8th grade level. So let's really work on our written skills there. Okay, let's go on with a couple of other examples. How would you show that the two triangles are similar? Looking here. Well, notice that angle sorry, I kind of lost my place. ABE and angle C are congruent. And notice that many of you are probably going to want to jump to the conclusion that angle E is congruent to angle D. But for that to be the case, the only way is if these two things were marked to be parallel. Well, they look parallel, but since they're not marked to be parallel, we can't assume that those are congruent. Now, if they were marked to be parallel, the property that would show that this is congruent to this, if you think about this, if these are your two lines, this would be your transversal. These two angles would be corresponding angles. But that's not the case. So we look at the third angle, angle A, and you see that angle A is a part of the small triangle. It's also part of the larger triangle. So what property tells us that angle A is congruent to itself? That's the reflexive property. So by the reflexive property, which is what you would need to say, because of the reflexive property, angle A is congruent to itself. Therefore, we have angle-angle similarity. Angle A and angle B is congruent to angle A and angle C. And then we would write the similarity statement. ABE is similar to AND And which angle corresponds with B? BCD. ACD. Okay? All right, please take a minute to solve B, and I will check this first thing tomorrow. You'll need to pause the video to come up with a solution for that, so I will check that. Okay, moving on. This is the last example. Can you please write and show that the triangles are similar and write a similarity statement. You little peekers are probably looking through my post-it notes. I'm going to cover that up good. So there's your problem. I will check that first thing tomorrow, as well as making sure that your vocab sheets are complete. Okay, that's pretty much it for today, and we'll see you tomorrow. Thanks.